solve some problems with vector spaces. So another problem, problem 5. Given that let S is equal to x1, x2, x3 belongs to R3 such that x1 plus x2 plus x3 is equal to 0. So find the basis. Find the basis for S. It is a sub-basis of R3. We have to find the basis for S. So it is easy to prove that S is a subspace of R3. It is easy to prove S is a subspace of R3. Now, to find out the basis of the S, so we have to given this equation that all the components of any point in S must satisfy this equation. So we will take any component x1 plus x2 plus x3 equal to 0. Now, if we take x1 equal to alpha and x2 equal to beta, then we will have x3 equal to minus alpha minus beta. So in this equation we need to take two variables alpha and beta, both belonging to R. So R x3 also belongs to this also belongs to R. Now any point can be expressed in S in this way: alpha beta minus alpha minus beta. So it depends on two variables. So its dimension is 2. It depends. Yes, depends. Any point actually. Depends. Any point. Any point in S. Any point is in S depends on two variables, not on three variables, alpha and beta. So we have two dimensions. So S has two dimensions. we have two linearly independent vectors. Dimension of S, that is dimension of S is 2. Now we have to find out the basis element. So we have many basis elements. We can take basis elements are infinite number of basis elements, but all the there are pair of basis elements. So there are infinite number of pair of basis elements. It will be infinite number of pair of basis elements. Finite number of pair of basis elements. All span is basis elements. So all span is like we can take one pair that alpha is equal to 1 and beta is equal to 0. Then the basis element will be one basis element will this implies that one basis element will be 1 0 minus 1 and alpha is equal to 0 and beta is equal to 1. This implies a basis element. This implies a basis element. This will be 0 1 minus 1. So these two elements form a basis for S. Another, we can take an infinite number of. In this way, we can take alpha is equal to any value C and beta is equal to 0. Then we will have one basis element C 0 minus C and alpha is equal to 0 and beta is equal to C. Then we will have basis element 0 C minus C. You can very easily check out that they are linearly independent. Just we have to find out one thing we have to remember that both base element must be uh, because they are elements of a basis must be linearly independent. So here both are linearly independent. You can check out easily. You can check out. I am checking this. This implies this basis element also. Here C belongs to R. So there are infinite number of pair of basis elements. Now, if we wish to checking linearly independence. So it is very easy to check out linear independence. This is alpha C 0 minus C is taken. I am taking lambda 1 plus lambda 2 0 C minus C equal to 0. If we solve this, we have lambda 1 into C is equal to 0, lambda 2 into C is equal to 0, and but one thing that C cannot be 0. C cannot be equal to 0. This is to be reminded. Otherwise, we have a 0 vector in basis element. This cannot be, 0 vector cannot be a basis element. So we cannot take the 0 element. And there is minus lambda 1 minus lambda 2 C is equal to 0. All shows that these three equations will be satisfied by C not equal to 0. So there must be lambda 1 is equal to 0 and lambda 2 is equal to 0. Its only one solution is the lambda 1 is equal to 0. This is the only one solution. Only one solution of these three homogeneous equation solution. So they are linearly independent. So they are these two form C 0 minus C and 0 C minus C, where C belongs to R and C not equal to 0. With this condition, we have basis elements are linearly independent. Linearly independent. So they must form the basis and they span also. Yes, so they must form the basis. So these are the basis elements. There are infinite number of pair of basis elements. Now another problem. Problem 6. Given that W, let W is equal to two matrices X, Y, 0, T, such that X plus 2Y plus T is equal to 0 and Y plus T is equal to 0. So we have to find out the basis element and the basis. Basis of W. So here we have given two conditions. These two conditions. If we solve this, then we will have x plus 2y plus t is equal to 0 and y plus t is equal to 0. So here, here if we put this in here, we is put in this first one, then we will have x plus y is equal to 0. This is another equation. So now, if we take t is equal to let t is equal to alpha. What will be y? From this we will have y is equal to minus alpha. And what will be x? X will be there. X will be there. Alpha. So what is important that all these matrices just depends on a single variable. All the matrices of 2 just depending on a single variable. So the W can be written down in this way. W is equal to this condition. You can write down alpha minus alpha 0 and this is alpha. So we need just a single element to we need just a single element in the basis element, not more than one element. So the basis consists of only one element. You can look this here alpha belongs to R. Alpha belongs to R. Alpha belongs to basis consists of only if we take uh, only the basis consists of only one element, a single element. You can take any value of alpha not equal to 0, then we can take this, we can generate basis consists of only one element. Only one element. So if alpha not equal to 0, then the dimension of the W is equal to 1. We need just one element to generate other elements. So we can take any value of alpha not equal to 0. So any basis element, there are infinite number of basis elements. There are infinite number of bases. There are infinite number of bases which all have just single element. Infinite number of bases which have